Welcome everyone to our webinar. We are so glad that you are here because it tells us that you care about unlocking the world's economic potential, and blockchain is enabling that today, as we will demonstrate with our success story. What drove us to showcase this solution is summarized here in this problem statement. Every day, financial institutions exchange trillions of dollars across different countries and different systems using processes that are slow, expensive, and unnecessarily complicated. And the barriers created by this process have become blockers to economic prosperity. In today's current state, commerce and trade can be arduous, even when multiple currencies are not involved. Add in the conversion of currency across borders, and an additional layer of complexity is added, taking days or weeks to complete. Authorization, clearing, and settling of payments occurs on different networks and at different times. As a result, we often see high transaction fees associated with digital and cross-border payments. And finally, there's little to no transparency in exchange rates, creating market inefficiency. Thanks to blockchain technology, the opportunity exists to simultaneously clear and settle payments on one network in near real time with cryptographic security and in a manner that is transparent. It's really not just a matter of efficient finance, although that is a great start. It's about granting access to a reliable currency in every part of the world. And with that, I am so excited to introduce the speakers: Jorge Ruiz, co-founder and CEO of Air Protocol, and Andrew Brick, blockchain engineer here at Object Computing. My name is Nikki Powers, and I will be your moderator. And without further ado, I am so happy to introduce Jorge. Jorge, can you please tell us a little bit about yourself and about Air Protocol?
Thanks, Nikki. Can you hear me?
Yep, we hear you loud and clear.
Perfect. Well, happy to be here. I'm really happy with your work also. You guys have helped us a lot to get where we are.
Thank you.
Air Protocol's base mission is to leverage public blockchains and cryptocurrencies to unlock the commercial potential of the internet. One of our core principles is we really believe in free markets and that everyone should have the ability to buy, sell, or exchange any legally acquired asset. Now, as a backstory, I actually started by co-founding another company called RTM around 5 years ago. And what we started seeing at that time was that people in Latin America and some other countries were adopting cryptocurrencies, not really because they cared about them, but because they really helped them with financial transactions they couldn't otherwise get in their countries, being because of capital controls or due to how the companies operate in those countries. Now, at that time, one of the things we decided to do was create a centralized service that worked as much as possible as a cryptocurrency, in the sense that we would allow people to have a store of value. We denominated in dollars. And we would do that by using peer-to-peer networks, in the sense that we would allow peers to interconnect, to buy and sell digital dollars against whatever, to put it in a way, off-chain payment system. Now, after a few years, and as the company started to grow, we also started to see there were a lot of issues, in the sense that in the case of Venezuela, for example, the government itself would try to avoid or block these types of services because they didn't want to have their population have access to the new financial services, or in the case of dollars, right? And that's kind of also how the whole project for the Air Protocol started brewing, where we saw the need to create a fully open source system that would allow to standardize peer-to-peer transactions, but worked totally decentralized such that it could not be blocked by having governments block IPs or malicious actors. And in the sense, also bring more transparency and immutability to the data you're transacting with. On the other hand, now that cryptocurrencies have matured a bit more, we're also able to do this in a more secure way by allowing people to have collateral on-chain by creating multi-signature escrows or smart contracts that allow that type of multi-signature mechanics. Now, the whole vision now for the Air protocol is to be able to create this permeating layer that standardizes any type of on-chain transaction against any type of off-chain transaction. And while probably the first use case you would come to mind would be fiat transactions, in the Air protocol in itself allows you to create decentralized marketplaces where you could have on-chain payments against the off-chain collateral of maybe receiving a sofa. You could maybe eventually create something like a decentralized Craigslist. You can create decentralized delivery of cryptocurrencies against maybe API calls. So the whole point of the Air protocol was to abstract the whole peer-to-peer mechanics that I saw and grew for the past 5 years into something that is useful for the whole ecosystem and people can build upon. One of the main features, and this is something that any peer-to-peer system will face, is how do you manage risk or fraud, right? So that's also why we abstracted the layer of how you manage dispute and the dispute resolutions such that it's flexible enough that people can adapt it to their needs, but also it serves in a way, given that we're using a collateral or an escrow of cryptocurrencies and multi-signature, we can allow people to facilitate transaction in a trustless way such that both parties know that their transaction is safe and they can have a third party check the transaction to mediate between them.
That's perfect. Thank you so much, Jorge.
Yeah, that's the basic core. I know that Andrew will go more into the technical details of the architecture, which I'm really excited about.
That's exactly right. So we're going to go ahead and we're going to move into the demonstration of this solution. And with that, I'm pleased to introduce Andrew Brick. Andrew is a blockchain engineer here at Object Computing.
Hi, everyone. Great to have you here today. So first, we're going to do a little bit of a roadmap to see what this demo really looks like and how the Air protocol really works. So on this next slide, you can see a diagram that describes the entire proposal, agreement, and settlement system, but we're going to break it down and take it piece by piece. So Air protocol is broken into two parts. One is a communication mesh network, and the other one is the Stellar decentralized ledger, which is used for settling and clearing transactions. So to get a little deeper into what that means, a mesh network is really just an information broadcast machine. So all of the nodes on this decentralized network are constantly broadcasting messages to each other in such a fashion that they're keeping track of who is being honest and how regularly, say, a connection is dropped. And by having a registry of their most immediate peers and a registry of what messages they've already broadcasted to the network, this peer-to-peer network becomes a great self-healing means of maintaining a network. It will sustain natural disasters. It'll sustain a lot of hacks. It really can hold itself up against bad circumstances, and that's what makes it such a reliable decentralized system. But how does this negotiation really take place? So in all trades, there is both a maker and a taker. This is true about regular trades as well. Now, in traditional finance, we typically use an adjudicator who will make our exchanges fair. In other words, when someone provides some kind of goods, say they're shipping you a package, it's hard to know that they'll ship you the package unless you pay them first. And if you're the one shipping the package, it's hard to know that you'll get paid after you send your package. So the question is, how do these two parties who have mutual benefit from, say, neglecting the deal, how do they come to trust each other? Well, in the regular world, we use third parties. We typically use lawyers or banks or the government. Sometimes people use credit card companies. There's all sorts of different agents who facilitate trades between two parties. But that's also really what's being changed here. So rather than a settling and clearing house, like any of those things I just listed, Stellar and Air Protocol will use this decentralized directed acyclic graph protocol, which is a type of decentralized ledger like a blockchain. Stellar uses this distributed network to keep track of all the information being moved around the network. And because there's so many parties keeping track of so much of the information, and it's so redundant, it's very, very high confidence that the information remains accurate, because it would be very hard to hack such a system, which is why we're confident moving finances on it. So again, as you can see in this picture, we have a maker and a taker. So a maker is a person, is an account on the Stellar network and on the mesh network, who will broadcast a proposal to the other members of the mesh network. That proposal will be considered by various parties, and if they agree to it, they'll send it back to the maker with an agreement. Now, they may have some counter offers where they negotiate exactly the terms, but what will ultimately most likely come out of this is that a maker will accept the taker or deny the taker's offer. And if both parties agree that this is going to be a good trade and they like the outcome, then they move to the resolution stage. So resolution could mean one of two things. Either resolution is they couldn't come to an agreement and the negotiation is over, or they could, and then it moves to settlement. Now, settlement is where the money actually moves around. We're no longer talking in hypotheticals. So what this does, this mesh network, is its own protocol for communication, and it is going to send calls to what we call the Horizon Stellar API. It's a microservice that runs on all Stellar nodes that allow you to communicate with and interact with the Stellar network as a whole. So what we have here is, you'll notice that from our settlement position, as we left the mesh, we are now entering into a position where we're looking at the buyer. Now notice that the maker and taker and buyer and seller are roles. They're not necessarily the same parties. The maker could be the buyer or the taker could be the buyer. And that's part of what I'm trying to demonstrate here in this diagram. So what's going to happen is, after the agreement is agreed to, resolved, and then pushed to settlement, the buyer is going to allocate a certain amount of money into an escrow account. So that's an account living on the network that will hold our monies for us while we finish negotiating this trade. And because when the buyer creates this escrow account, he makes it so that he only has a partial authority over that escrow account, and can only partially determine what happens to the monies in there. The rest of the authority over that escrow account is given to both the seller and also the jury that they agreed upon when they pushed this negotiation over to settlement. So what that means is, when they agreed that they were going to be making a trade, they also decided who their third-party adjudicator would be, right? Again, in regular life, we use lawyers, banks, or the government. In this case, the jury could be anyone who happens to host that account. It could be the Better Business Bureau. It could be a lawyer. It could be, a series of professionals trained in a very specific skill set associated with this trade. It could be a whole democratic organization unto itself. But the point is, the buyer and the seller are both relying on the jury to decide whether or not the transaction was completed in good faith. So you'll also notice this fulfillment option. This is really where a seller or a buyer will provide evidence that they've fulfilled their side of the bargain, such that the jury can make their decision. And I think we just went over everything. So what will ultimately happen is, when the agreement is settled, if it was settled in a fashion that was valid, then the seller will end up taking the monies, and the buyer will end up receiving whatever goods they saw fit. If it ends poorly, then depending on the agreement, some money will go to the buyer and some money will go to the seller, and it could very well depend on how they negotiated in the first place. But we're going to go ahead and jump right into the live demo now that we have some kind of vision for where we're going with this. So I have that as the background just to keep everyone in the know. I'm going to open 4 different terminals here. And I'm also going to open this notepad. Now, on this notepad, I have copied and pasted commands for the sake of this tutorial. But in actuality, you can find every single one of these commands within our repo itself. So we're going to go ahead and SSH because we are currently running the AIR protocol in AWS server. So I'm with each one of my terminals. I am getting into our server. Okay, great. And now I'm going to enter into the proper directory. On each one, they all use the same directory. Okay, so now we have 4 different terminals open. Now, to try and keep track of these a little bit better, we're going to name them. So we're going to name this first one boot node. So now you can see it up there. It says boot node. And let's go ahead and start it up. So this boot node can be considered the first and only node necessary to start up a mesh network. If you were to start up more boot nodes, your mesh network would simply become bigger, be able to broadcast faster, and be able to handle more messages. But for now, we only need one. You can really make as many as you like. So this next one, we're going to make our jury. And we have to start up that client. So just to be clear, in blockchain, we're typically used to hearing this term full node, which is something that hosts the primary protocol, maintains a consensus algorithm, and keeps the network honest. Now, in this system, when I talk about the boot node, that is a full node for the mesh communication network. It's not a Stellar node on the Stellar distributed ledger network. Those are 2 very different things. Another thing worth noting, there's a very big difference between a node and a client. So our boot nodes are all central to the communication networks. The communication networks are always propagating their messages over a series of boot nodes, whereas our users, which will be in this case Ricky and Lucy, are edge clients. So they sit on the edge. They don't actually propagate any messages except for what their users want. And they can interact with the network. They can set up trades. And we're just starting up now Ricky. And then we have our very last one, which is Lucy. So let's go ahead and name Lucy. And let's start her up. Cool, so now we have, not only do we have Lucy and Ricky, but we also have a boot node and a jury. So I'm just gonna drag these over here because we're not really concerned about the boot node and the jury for now. The boot node will relay any message that we send through, so we can always go back and see what's being moved between these 2 parties. So now what I'm gonna do is I'm gonna take this proposal command and I'm gonna submit it as Lucy. So Lucy is going to be asking to buy, in this case, peanuts for stellar lumens. So that makes Lucy is the buyer and the maker in this context. So there we go. She just made a proposal. So now we can actually see the proposals right there. And you can actually prove that they've been propagated across the network because Ricky can see them too. So now as Ricky actually really likes this deal. He wants to sell those peanuts. So here he goes. He accepted the deal. And then if we go back over here on Lucy's end, she can check the offer history of this offer she had put out. And she can see that it was actually accepted by this taker ID, which happens to be Ricky. So that means that they're coming to terms with this agreement, which is great. So Lucy says, this is excellent. Let's resolve this. I like making trades with Ricky. So she resolves. And again, we can see in the offer history that resolve message. And then she's going to settle it. And this means that we're now moving the message over to the Stellar network. And you'll notice that this takes a little bit longer because it's calling to an API. But that indication, that message with no error, is an indication that it worked. And we can actually see more evidence of that right here. Settlement initiated with escrow ID. So what's actually really cool is we could take this escrow ID and go to, say, a Stellar Explorer. And we can actually see this escrow account. There it is. So this is actually on a public network. Anyone who's connected to the Stellar network can see this. And that's exactly what keeps us all honest in this process. So excellent. Let's go back to our demo. So now that the escrow ID is all marked up, we can submit a fulfillment. And this just really, again, it just adds evidence. Fulfillment is optional, but it adds evidence to a jury should they have to make a ruling as to how the negotiation went down. You know, this is very similar to when, say, a package delivery company will send you a picture of your package on their porch. That might go in the fulfillment spot in an air protocol exchange. So Lucy agrees to everything that's happened so far. So she's going to disperse her money. And actually, she's now relinquished her control over the money. And now it's up to Ricky to go and retrieve his money. We can't force it to him, but and that actually shows a seeming error, but that's actually a new issue. It's not actually a real error. I think it's a reporting error. But we can show you. That look, we went through the entire situation and we actually dispersed those funds. So this trade is now complete. And by all regard, that evidence should prove that Ricky fulfilled his end of the bargain and Lucy should now be satisfied with her position in this exchange. So that's really great. And we call that the happy path. That's when everybody agrees and everything goes great. But I think now it's time to discuss why we have this trust issue in the first place, right? Why do we build these settling and clearing companies? Why do we have credit card companies? It's because it's very hard to get these parties to agree. And oftentimes there is actually lots of issues that require customer service or require a refund or some sort of problem went down in terms of this exchange. And we need a way of mitigating those kinds of problems. So we're going to run through another scenario now. So I call this one happy path. This one's called sad path because not everybody gets what they want right away. So Lucy's going to propose a totally new proposal. And again, see our proposal there. This one's called CDE. And she's again looking for peanuts. Now she wants even more peanuts. Ricky thinks that this deal's pretty good, but he wants to counter offer. So if he looks at the offer history, CDE 1, 2, 3, 4. Then you'll see that he actually proposed a different trade. Lucy, thinking that this trade is acceptable, agrees. Then she resolves. And then she settles. Prepared fully to take her end of this deal that she just agreed to after Ricky made his counteroffer. So that all worked. And again, we can look at that offer history of CDE 1, 2, 3, 4. And we can see that the settlement has already initiated, but now it's up to Ricky because actually in this scenario, Ricky is upset. He did not like how his package arrived. He didn't think it got there on time, or, he just decided that this deal wasn't for him. And due to the nature of the agreement that was already set forth, he's in a position to dispute it. So we're going to submit that adjudication dispute request by Ricky. And you can actually do this at any point in the process after it's already been pushed to the Stellar network. So now there is this debate. There's this issue where the parties are not agreed upon what is going on. So we need to turn to a third party. In this case, this third party is the jury. We haven't actually used the jury yet, but we're going to right now. The jury was already assigned per our original agreement to be our adjudicator in this situation. And we can see that there is a proposal in dispute. So we're going to dig a little deeper. And the way that this works is it asks that you dig deeper because there could be quite a lot of information in here. So it asks that you take step by step, and we can see even more so. We can see the sender and receiver. We can see all of the claims, and this is actually the fulfillment evidence that was appended to the proposal. So, and now we can go even a layer deeper. So now we're going to view the agreement. And this is everything that we know about the agreement to this degree. And this agreement is considered valid. There's everything holds true to what is known in the public space. So the jury is going to agree that this is valid. And we can actually even see that now, that the agreement has been ruled valid. And now we're going to finally do our ruling. So after all is said and done, after reviewing the evidence, the jury decides that Ricky has been right I believe it's Ricky who is correct. So in this case, we decided that the buyer is correct. So if we recall, Lucy made the proposal where she asked to purchase peanuts. Therefore, Lucy is the buyer. So this ruling by the jury is going to say that Lucy is the victor of this exchange. Great. So now what that does is, much like our prior disbursement situation, that now enables, and it will actually send this message to both parties, that will enable Lucy to then submit her disbursement. And again, this is a reporting error, but it actually shows that Lucy has been fully dispersed her funds as ruled by the jury. So that is a complete end-to-end demonstration of both a successful and unsuccessful trade that ultimately was resolved by the jury. And what you'll notice here right away is that the capacity for automation in future financial organizations and trades, it's profound. We can really take things to the next level when we can assign juries on a fly, when we can make various different programmatic conditions, because the jury may not even necessarily be a party. It could also be controls. It could be a sort of smart contract or a microservice that maybe disperses certain things based on certain criteria. So for example, if we wanted to do a financial transfer where someone wanted to trade US dollars for Stellar, what I might use as my fulfillment evidence is like a PNG or a JPEG of a screenshot of my bank account that indicated that I transferred the adequate money to you. And then you could create, say, like a microservice or something that acts as a jury that waits for explicitly those kinds of messages. And when you really have flexible organizations like this, when you have flexible settling and clearing like this, not only can you do vastly more trading for way cheaper and way more efficient than ever before, but the point is your books are all kept in sync. Your entire accounting, as insofar as this kinds of collections is concerned, is contained for you within a single database that really isn't going anywhere. The likelihood that this database gets truly expunged and inaccessible is virtually none. So we can now confidently build more impactful, more potent financial systems on top of existing systems and make them faster, more efficient, and connect people to really help them make trades faster. Now, one other thing worth pointing out is, obviously we just went through a bunch of command line commands, which were all very text specific. If we actually go ahead, and I'm going to go ahead and finish our demo right here. But if we actually go ahead into our repository, we can see that the prime engineer on this project, Dorian, very talented guy, put together this excellent walkthrough, which does precisely what I just did for you guys, with actually even more explanation and more information as to how cases might diverge or how you might handle edge situations. But really, what's so great about Air Protocol and what we've built here is it's both simple and incredibly powerful in its simplicity. There is very little room for problems when it comes to getting people to be seeing the same information, knowing what they're agreeing to, and settling and clearing that information. That is extremely transparent and extremely well isolated to all the parties involved. And we actually even have instructions in here on how you can attach this kind of thing to a front end interface and get started with like a GUI or an app or anything like that. But what Air Protocol has built here is really very open-ended, and not only is expansive and potent when it comes to the financial world, but really in the entire world of organization, of organizing your business around systems like this will make everything just flow vastly more clearly and fluidly, because everything is just in front of you and just one query away. And that's really what Air Protocol is doing so differently, is they've made a way for us to make these exchanges without paying out, without shelling out all this extra money to credit card companies or banks or whatever. We can now take ownership over our own means of exchange and make for better outcomes for really everyone as we create a more efficient economy. So I'm going to go ahead and hand this back over to my moderator, who's going to be taking some questions. We're going to do our best to answer them for you.
Thanks so much, Andrew. This was a really helpful demonstration. So we would like to introduce any questions from our audience. If you have questions, just go ahead and type those into the chat box there. We've already got one question, and I'm not sure who's best suited to answer this, possibly Jorge, possibly Andrew, or possibly both of you. But Jorge, one of the things you said early on in the presentation was that this works with cryptocurrency. So does it work with regular currency as well?
Yes. So kind of like Andrew was saying at the end, the main purpose of the Air Protocol is not only to be cryptocurrency, I guess, focused marketplace or system, but in general, a value exchange system for any type of value. Now, the main purpose of using a cryptocurrencies here is not necessarily their own denomination or the value of the cryptocurrency itself, but leveraging the properties they have so we can create secure transactions by having immutable transactions, having the multi-sig escrow, and just in general ensuring that there's a secure exchange of value on both sides.
Yeah, absolutely. And also, just so everyone knows, what's kind of cool about this is also encrypting these data packets as they flow through the mesh network, as well as the fact that on Stellar, everything is packaged in an XDR format. So in terms of what data is visible, not that many compromises even have to be made on the organizational level to take advantage of this next level efficiency that can really be achieved in a way that's unprecedented. Not only can we exchange regular old cash and traditional fiat currencies for cryptocurrencies or other value exchange using Air Protocol, which is profound, but actually even outside of exchanging those real terms, there's also a function on the Stellar network where people will tokenize, they'll create stable tokens, they'll peg an existing token or an existing currency with a token on the system and assure that, the euro tokens on the system are backed by a bank actually holding a commensurate amount of euros. So what's really cool about this is it's very open-ended. Really, that fulfillment is what it comes down to, is if you can express the fact that you have done your side of the bargain in terms of a fulfillment, you can really trade anything you want on here. You could even do this for labor. You could have contractors who publish evidence that they've done their job. Within the fulfillment, you could even make terms where the escrow pays them out as they achieve each portion of the labor requested. There's really so much you can do here with so little. It's really a next generation way of exchanging value. It's really something to behold, and really emblematic of the kind of change that distributed ledgers are making in this economy right now.
Thank you for that. And again, just type in your questions in that chat box and we'll go through them one at a time. We'll read them out loud here. So the next question is, you've talked about the Stellar protocol a number of times. Why did you select Stellar? What are the benefits?
Yeah, so Stellar is great. One of the reasons why we really like Stellar is a highly decentralized system made of a very reputable entities, mostly banks. Something like 2,500 banks hold up the Stellar network. Each one is running a computer maintaining this network, not unlike the Bitcoin network, although this system, this consensus mechanism is vastly more efficient. It doesn't cost as much energy, it doesn't cost as much money, and can be maintained much more confidently. But what we really, really like about Stellar is is intentionally finite in what it will allow a developer to do. And that's what makes it so clean and clear and gives us such great confidence in its ability to operate efficiently and effectively. Is Stellar is not Turing complete. It's what we call an automata-based network. So basically, it's a state change machine. So you can't really change how it's going to behave without knowing exactly what state it's in and what state you're trying to get it to. And what that means is you can't really have in Stellar without, some sort of microservice or third-party server or some other additional augmentation. You can't really build something that's based on, say, if the White Sox win the World Series. You can't really make a smart contract that does that naturally. You can make an outside piece of software that behaves and makes checks on those kinds of things. But what's really cool about Stellar is the variables are so few. There's so little gray area in what's going on that we can achieve a much greater degree of confidence and a much more safe financial environment.
I would just maybe add to the question or the decision of using Stellar that it's a very transactional focused blockchain. And the fact that it's meant for exchange of value, it has already some underlying properties that make it ideal for financial services or other platforms to adopt it. And it's also very fast in terms of the transactional, let's say the time it takes for the transactions to be confirmed on the network is a lot faster than other more generic blockchains like probably Ethereum.
Absolutely. Yeah, you'll notice during our settle and clear commands, those wait times were somewhere around 3 seconds, 4 seconds. That's dramatically faster than the vast majority of blockchains. Certainly, considering the degree of adoption it has, I think Stellar is way out in front for having this degree of efficiency and adoption at the same time.
So I'm curious, did you consider other blockchains prior to landing on Stellar?
This actually was a discussion that you guys helped us to go through, but yeah, we went through a lot of most popular networks, and we went through the properties of what we wanted to create, what mattered the most. We ended up settling with Stellar mainly because of what we talked about, which was fast transactions. It's very, assets and transactional focused, and the actual fact that it's not Turing complete, so that smart contracts are not as general, actually in this case provide more benefits than, well, we really did not need anything else, right? So it made a lot of sense.
Yeah. And if I could just take this opportunity to really drill down into, not only is Stellar is well suited for this job, but it really was our best, what we felt was the best implementation of an idea that's happening all over this industry. and a concept that Air Protocol is really taking ownership of and taking a first step on. And it's really hard for a lot of people outside of the blockchain space. It's a lot of hard for a lot of people in the blockchain space to understand just how much of this kind of white collar administration has to go on when it comes to all of the numbers that we move around. At the end of the day, on the stock market, there's always Goldman Sachs and JP Morgan and all these major banks and major hedge funds will send their end totals for all the trades they made to what's called a clearinghouse. And the clearinghouse checks up all the numbers and makes sure that the parties who are trading everything only trade the least amount that needed to be traded in order to get everyone back to where they should be. That process is enormously expensive and takes a very long period of time. Another client of ours had told me that it costs upwards of $1 million to transfer $30 million over the ocean if you want to get it there within 2 weeks. And that's a crazy portion, right? That's something like 3% cost, much like when you go to the ATM and you try and take out money, it's some like $4 or $5 charge just to be able to take out something like $200. This is exactly the kind of market inefficiency that Air Protocol can help us solve. But what's really hard to picture until you really get a chance to take a hold of and play around with the Air Protocol is that this is more than the sum of its parts. When you take a car off the road, the traffic improves to some degree, but when you take 50 cars off the road, it improves dramatically. And that's exactly what Air Protocol is doing here. It's greasing the wheels of commerce in such a way that like much more value will be found and much less lost in a way that people have a hard time keeping track of it. So this really is it's the dawn of a new organizational structure in society, not only with crypto, but especially with Air Protocol and how we make value exchanges.
There's a book highly recommended called The Compound Effect. So it's similar to what you're describing there. So from a security perspective, you're talking about the clearinghouse, and as traditional finance has always operated, we go through these processes, and arguably it's because we need to ensure the security measures are being followed, that people are only being charged what they've agreed to pay, and that everybody gets what they think they're getting at the end of the day. So what makes Stellar better than those processes that exist today?
That's an excellent question. Stellar is dramatically better for a variety of reasons. So much like Bitcoin, much like Ethereum and any other blockchain style system you've heard of, Stellar runs on a consensus algorithm. So a consensus algorithm is kind of like democracy. It's how these computers come to an agreement about what it is that they're seeing, what it is that they feel they're processing. And in Stellar, it's based on a series of quorums. So basically what happens is collections of nodes are rapidly changing which, say, voting group they're in. And all the voting groups together are constantly having to commit to their votes. And basically what falls out of this, it's a little oversimplification, but what falls out of this is that it becomes very hard for a single node to do anything without his quorum agreeing. And it's very hard for his quorum to do anything without their quorums all agreeing. And what this means is that altogether, it's very hard for anyone to disagree with the network using the network. It's very hard to push out false messages or say like 51% attacks or forks as they might be called in Bitcoin. It's very, very hard to propagate those messages out. And part of the reason for that is because Stellar is so fast. Stellar is so fast that before lies have the time to propagate across the network, the truth has already cleaned itself up, which is, very reminiscent of maybe the corollary of that old phrase about truth getting its boots on. But yeah, this system can really identify consensus immediately, and because that there isn't really room for dissent, so far you can certainly have a node that misbehaves, but what won't happen is the other nodes won't endorse its behavior and they won't accept it, and as a result the whole thing becomes very, very confident. It would take an a massive amount of collusion for someone to propagate a false message on this network. It's dramatically more confident than any existing clearinghouses are today.
Jorge, how do you respond to that? Would you say that went into the idea phase of this solution, or did that come along as an afterthought?
No, I think it's a core part of the idea, and more on not necessarily on the consensus part, which I think Andrew explained well. There's the other part where currently or in traditional systems, you are also trusting the entity fully, right? And one of the, I guess, virtues of blockchains in general is bringing transparency. Not only because you trust the distributed ledger and that everything is went through a consensus, but more that you can actually audit transactions on chain and ensure that they make sense for external parties, and you can audit the way the organizations behave doing transactions on chain. Now, also bringing the ability to kind of separate systems into smaller pieces or even into points where peers can have control of funds. I think that granularity also brings more control for people, so they know they're in control of their assets, or at least they can check that the assets were used properly and how they wanted. And that was always one of the core beliefs of the Air protocol when creating the system, bringing that transparency and allowing people to have more control of their value.
And I think another thing that's really important here that maybe we've neglected on a little bit, but is true for all blockchains, is this system also has a tremendous amount of traceability to it. So while in many ways it's introducing greater freedoms in terms of how people exchange goods, it's also creating greater accountability because, say, the funds in a given account, they can't really run away without being, without visibly moving on the network and being tracked as such. So people are kind of held, their account at least is held to a greater degree of responsibility than they might in, say, like a cash trade or some other type of fiat trade. There is a much greater degree of, say, staked reputation and visibility of people's behavior on this network. And maybe that behavior is anonymized, but regardless, if an account starts acting like a bad actor, the entire network will start to notice, and that will become a very easy way for us to find and root out the bad actors in the system. And that's really something that a lot of free market solutions have not been able to provide up until like the age of decentralized ledgers begun.
So I'd like to turn the question back to the audience, and I just dropped a chat into that chat box there. I'm curious, what interested you most about today's presentation? What prompted you to join today's presentation? What are you most curious about? We want to know, because that will help us produce additional webinars and web content that will help answer those questions for you. And we encourage you to follow us on Twitter at Object Computing, and also check out our website at objectcomputing.com, where you can find links to future webinars and podcasts and blog posts and conferences, all of which are designed to answer questions just like the ones we answered here today. So we've got one response from the audience, what interested you most, and Vishal says blockchain.
So just a word of clarity here. Actually, Stellar is not a blockchain. Stellar is what we call a directed acyclic graph. So if you were to draw it on a piece of paper, it would look very similar to a blockchain, but with kind of a bunch of other tiny chains breaking off. And what that allows us to do is basically, rather than needing the entire network to come to an absolute certain alignment, which is basically what happens in Bitcoin, it comes to a very confident alignment that it then increases the confidence over time, assuming nothing went wrong. And this allows the system to operate dramatically faster without really losing any tangible amount of confidence in the legitimacy of the ledger. So that's one of the things that really makes Stellar one of the the version 2 or 3 of this blockchain world. It's dramatically faster than anything that existed in the blockchain alone space.
We have another comment from the audience. Ron says he was interested in learning about how information flows through the networks. So I think this visual is pretty appropriate for that.
Yeah, and I can actually add a little bit more information about that. So the mesh network is really something truly special. It's very homegrown at OCI. A lot of the Stellar stuff, is built off what the Stellar Foundation has built, but the mesh network is truly homegrown. And what's really cool about it is basically it's a series of nodes who are aware of their peers, and they're always propagating out messages as they see them, making sure that they're unique. And because they're constantly making sure that they're unique, it keeps the airwaves, so to speak, clear of traffic, and information flows very, very fast. It's an extremely efficient network for getting information out to where it goes. It's WebSocket based, and because that's really the best way to get real-time stuff over the internet. And right now, it does rely on traditional HTTP. It can run in the cloud. We've already run it in the cloud on GCP and AWS, as I showed you guys. But it really is. It's a hyper efficient network, and the degree to which it can spread information so quickly is exactly why it's resilient to things like natural disasters or hacks.
I would just add one thing for the comment on the interest in blockchains. One of the other focuses of the Air protocol is also bringing useful infrastructure to bridge traditional systems to new technologies like blockchains and new financial services. And one of the issues that it's clear now is that while blockchain itself or cryptocurrencies are a great technology, you need to bring adoption. And to do that, you need to be able to create this type of infrastructure which bridges access to those services and to those cryptocurrencies in order for them to grow. And I think that for some time, a lot of the projects have been focusing more on the end purpose of creating the technology rather than the technology itself being useful for the masses and to create those bridges.
Hey, Dan, we see your question here. You said that you are also interested to see how to extend these ideas into non-financial transactions, proof of work, proof of credentials, verifiable attribution behaviors, etc. I'll tell you what, in fact, in the system that we just showed you, you could do that right now, doing no financial transaction whatsoever outside of the minimum transaction fee required by Stellar, which is something like 0.03 cents per transaction. But you can absolutely do things like, authentication mechanisms. You could do IoT authentication mechanisms. Stellar was not really designed for a lot of those things, but it's actually pretty friendly to them if you just put in a little bit of work. For example, there's a memo field in there whenever you do any sort of transaction. So if you were to send, say, a one microstellar transaction with a memo, you could store, say, maybe a hash in that memo, or you could store a link, you could store an IPFS link. You could really do a whole lot with just the opportunity to put a memo in there. So if you're looking to do that with Stellar, I would recommend maybe looking in that direction. But if you're looking to do it with other blockchain systems, there's other ones that are better for other things. It really just depends on what your goals are. And I also see a question from Tim Waterloo. I am most interested to learn how the application is being used in the real world. Maybe Jorge can speak a little bit more to how customers have been adopting, but certainly AirTM had quite a bit of an adoption, and this is really an augmentation and decentralization of what AirTM was accomplishing before. So in a way, its deployment is a little less top-down and a little more bottom-up. But that being said, I mean, it certainly offers the opportunity. You could easily put a point of sale front end in there and then immediately make this your, point of sale modal for whatever it is that you're doing in your business. You could even run a very traditional business on this entire system. And you know what, if you really wanted to, if you wanted to go full just people don't even know that they're using blockchain kind of thing, you could leverage something like one of various different systems that allow you to transfer credit directly into cash on demand. Like I know BitPay is one of them, but there are several others. You could easily leverage that with a front end to completely obfuscate away the fact that a distributed ledger is being used while still giving people the full confidence that they're receiving exchanges. I don't know how. To what degree people have already done this, but also, I mean, like this particular decentralized version of Air Protocol has only been live for a very short period of time. So we're still seeing adoption. Is really what I
from the side of mechanics. The base core of how the Air Protocol works is already being used live in other systems. This is an extension which actually is also meant to be extended and aggregate multiple platforms, but you basically are able to exchange any type of fiat currency for, you can have dollar denominated value and create e-wallets. You don't actually need to show users that the system runs on a blockchain or it's distributed. What matters is that you can allow people to transact, let's say, a local bank transfer between themselves or a purchase against an electronic currency, which can be, I don't know, Mexican pesos, US dollars. It doesn't necessarily need to show it's crypto. And so the use case, you can see this type of peer-to-peer networks work in the real world with, let's say, RTM or local Bitcoins, or even maybe exchanges. Let's say something like eBay, you're actually exchanging digital dollars against an asset. They could be using the same protocol and you wouldn't know that it's using cryptocurrencies or blockchain.
Thank you, Jorge. And thank you everyone who joined the webinar. We do need to wrap up. We're at the top of the hour. Thanks again, everybody. Have a great day.
Thanks, guys.
Thank you, Jorge.